Hi, this video is about one of the most common misconceptions of Newton's third law of motion. Newton's third law of motion says that for every force, there is an equal and opposite force. The forces are equal in magnitude, but they're not equal in their effects. So, as an example, a 70 kilogram skydiver is being pulled toward the Earth with a force of 700 newtons. 700 newtons down. According to Newton's third law, then that also means the Earth must be pulled up by the skydiver. So, equal and opposite forces, the Earth pulls the skydiver down, but the skydiver pulls the Earth up by Newton's third law. So part of this says that the forces are equal to each other, which doesn't seem right because clearly the Earth isn't really falling up like the skydiver is falling down. The skydiver is very clearly being pulled down to the Earth, but it doesn't seem like the Earth is being pulled up towards the skydiver. But that's where the misconception lies. The forces are equal, but the effects of the forces are not equal. For the skydiver, the effect of being pulled down to the Earth at 700 newtons of force is that this skydiver would accelerate towards the Earth at 10 meters per second squared downwards. And we're using Newton's second law to calculate his acceleration. On the other hand, the Earth is being pulled up with 700 newtons of force. However, the Earth has a different mass than the skydiver. The Earth's mass is 6 trillion million kilograms, 6 times 10 to the 24 kilograms. So when we calculate the Earth's acceleration, we find that it's a very tiny amount of acceleration upwards. So while the forces on the man and on the Earth are equal, the effects of the forces or the accelerations are not equal. And that's where the real misunderstanding lies. We think that the effects of the force should be equal and opposite, but that's not what Newton's third law says. As another example, a rocket accelerating upwards away from the Earth pushes its fuel down, let's say at a force of 1 million newtons. So you're being pushed down 1 million newtons of force pushing down on the fuel. The reaction force to that is the fuel pushes the rocket up at a force of 1 million newtons. So the forces are equal, but one of them accelerates a lot more quickly than the other. The rocket accelerates upward at a relatively slow rate. If you've ever seen a video of a rocket launching, it starts off very slow and gradual and it begins accelerating upwards. It does get up to high speed eventually, but it takes a while, so it has a slow acceleration. On the other hand, the tiny little fuel particles that are being blasted out of the rocket's engines are accelerated at extremely high rates downward. They're moving much faster than the rocket is. That doesn't mean that there's more force pushing down than there is pushing up. It just means the effects of those forces are different. They both are 1 million newtons of force in this case, but the tiny fuel particles with very little mass are accelerated much quicker than the very large and massive rocket. So the rocket accelerates relatively slowly. One more common example of this is a ladybug hitting the windshield of a car. This is a great example to really help you understand the difference that we're talking about here. So let's say you run into a ladybug as you're driving. The ladybug hits the windshield of the car. And so the car applies a force of, let's say, 1,000 newtons to the ladybug. All right, that means, according to Newton's third law, that the ladybug must also be applying a force of 1,000 newtons to the car's windshield. So we have an equal and opposite force still, 1,000 newtons to the ladybug and then 1,000 newtons to the car's windshield. So the forces are equal, but the effects of the forces are not. Since the ladybug has a very tiny mass, it will be accelerated extremely quickly to the point where we can probably say goodbye to the ladybug. The car, however, has a much bigger mass, and it's not going to be affected much by 1,000 newtons of force. Even though it's a lot of force, the car's mass is just so big that it doesn't really do anything to the car. Now, if we have bigger and bigger objects running into the car, then the car may start to accelerate a little bit differently. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.